Hi, everyone. We are live again. Welcome back to our Thursday live stream. So today is going to be a little bit different. Today it's going to be an Ask Me Everything, Ask Me Anything, and so there's gonna be a lot of challenges ahead with the next school year. And we don't know, are you going to be teaching in person, are you going to be teaching at home, are you going to be teaching in a hybrid situation, distance learning, are your students going to be doing hands-on experiments at home? And so whether you want to have at home whether you want to have at-home science kits or a different kind of demo that you do online. I'm hoping that we'll be able to answer some of your questions today. So I'm Danielle Snowflack. I am the Senior Director of Ed at Edvotek. Let's get started. Okay, I just got a message that there was an echo. So are any of you in attendance hearing an echo, or does it sound okay? You can let me know in the chat window if you're having problems. But, we're going to try and keep this. I want to make sure that you can hear everything well. So if you're having any tech problems, let me know. Again, I'm Danielle. I'm here to help you, to answer any questions, and let's get started. So many of you have been with us for a while. You've gone to multiple of our live streams, but just a little bit about Edvotek. So we are the biotechnology education company. We were founded over 30 years ago by Dr. Jack Churchian, professor of biochemistry at Georgetown. The 1980s were super exciting for biotechnology. And that's because of many of the technologies I featured in our past live streams: DNA fingerprinting, restriction enzymes, polymerase chain reaction. These are all, recombinant DNA being used to make medications like insulin. These were all really just fantastic inventions and creations and applications of biology to these industrial type questions. But little of that was being translated into the classroom. And that's where Edvotek came from, a place where we wanted to invigorate and excite students using technology that was real and relevant in the laboratory. And so, I always talk about that part of it, but since the beginning, we have been really invested in teacher professional development through workshops at conferences and other events that we've hosted over the years, plus, getting small business grants to develop educational resources and training programs. And so, we talk a lot about the experiments we're doing, but we are also experts in helping you implement those experiments. And so that's a little more of what we're going to be doing today, is help focusing on the implementation. We focus solely on the education sphere, where we work with educators from all over the world to demystify science and foster the next generation of scientists through hands-on active learning activities. So preparing for the 2021 school year. So let's get down to business. In the midst of our current global pandemic, I think it's fair to say that this school year will not look like school years from years past. I know everyone is making plans for fall instruction, but those plans could change in any minute. So we have teachers who have hybrid schedules where they're teaching half in class, half online. We have teachers who are fully in class. We have teachers who are fully remote. And given the circumstances, those can change at any minute. Should something happen and the number of COVID-19 cases spike in your area, your school may make the decision to protect everyone's health and to go fully online. Or things could be going great in your school district, in your area, and their school district could make the decision to go fully in person again. And so, I think that, we are here to support you in any way possible to help you be able to react to what's going on day to day and week to week. So in this live stream, I'm going to answer some common questions that we have received from educators and provide some tips for distance learning. This is not a comprehensive list. I want to make sure that you know that you can ask questions at any time during this live stream and I will answer them. I have picked a few of their most common answered questions, but I actually have one in the chat window that I'm going to answer too, because, it's a great question. We weren't asked it beforehand. And it's a great point. So I'm actually going to bring that up when I'm done with this little recap. But in addition to this live stream and this Ask Me Anything, we are always available if you want to call or email us. You can call us 1-800-EDVOTECH. You can email us info@edvotech.com. And one of our technical support scientists will work with you to help you implement your experiments as best as possible. This discussion is being recorded, and the slides will be available on the website. If you'd like to be notified when they're posted, please be sure to fill out the survey that is in this chat box that's been posted. And if you have any other questions or comments or concerns about the way the 2021 season education year will go, we're thinking about a new time to have these live streams so that everyone can attend, because school is going to be back in session and people aren't going to be able to attend in the middle of the day anymore. So if there's a time you would prefer, please put that in the comment form, and really let us know what you're thinking. Furthermore, if you want, we are offering professional development certificates for this live stream. So if you would like one, please check that box in the form and we will email it to you within a couple days. So we're only because we want this to be meaningful. We want to make sure you've participated. This link will only be active for 1 hour after the live stream. So be sure to complete it by 3 p.m. Eastern time. So I did see one question from Thomas in our live chat. So thank you so much for coming with questions. The question is in Kit 225 in the preparation for Module 1. So Kit 225 is a DNA fingerprinting using restriction enzymes kit. So it's a DNA digest with preparing the reagents. So preparing the restriction enzymes for Module 1, because they have one group of students that are Monday and Tuesday and a completely different group on Thursday and Friday. And so this is a great question for this experiment. I'm actually going to handle this a little bit later for the ELISA as well. But what we would recommend is that, when you're preparing for your Monday, Tuesday section, you're going to prepare the dryzymes as listed in the literature. And then what you're going to do is aliquot for the 2 sections. So if you have 10 groups, make your 10 aliquots. If you have 5 groups on the Monday, Tuesday, and then 5 groups on the Tuesday, Thursday, Friday, what you'll do is take 5 groups of enzymes and put them in the freezer. And you'll leave them in the freezer until Thursday when you're ready to do the experiment and thaw them on ice. The enzymes the enzymes will be stable for that time period so that you would be able to prepare the experiment for both groups. Now, I probably wouldn't leave them in the freezer for 2 or 3 weeks. I'm sure they would still be good. But for the best results, I would use them within that week period. Do you have and if there's any other questions you have, any follow-up questions, Thomas, please just put them in the chat window. I'll be sure to follow up with it. So, as I mentioned, we do have a lot of kits which have perishable items, and that is probably an area of anxiety for some of you. You think you're going to get your perishable items in the mail and they're going to need to be used right away. And we've gotten a lot of calls about this, so it's probably our number one question. But don't worry, we have you covered. We are realistic and we are trying to work with our instructors as much as possible. And so I would order your experiments as you do every year, even those which would have temperature sensitive or perishable reagents, because we aren't shipping perishables until you ask us for them. So you actually will have a perishable certificate that will come with your experiments. It will be in the box and you'll open it up and you will call us with that perishable coupon and it never expires. So if you order a kit this fall and you can't actually use it until the spring, what you would do is call us in the spring with that perishable coupon. If you have an experiment for this fall and you can't use it until next fall, that perishable coupon is still good. You're covered. You buy the experiment and we will make sure that you will be able to use it in your classroom. The only suggestion I make when coming to perishables, especially if it's a following school year, so let's say you wanted to do a transformation in the 2021 school year and you don't get to do it until 2021 22. I would just call us to make sure that there haven't been any protocol changes, because your kit will come with a specific protocol number. And if we made any updates, we want to make sure that you have, that everything combines well, and that there aren't any problems with compatibility. And there shouldn't be. Oh, I got a frog in my throat. There shouldn't be. But, we just want to make sure that everything is going to work well. So if you happen to receive your perishables and plans change, most of them are good for 9 months if stored at the proper temperature. So what you're going to want to do is, if you order the perishables, the minute you get them, go to your protocol in the instructor's guide. There's a page that talks about the components are also labeled, but it will tell you the table of contents page will tell you the best temperature at which to store your reagents. And most of the reagents are going to, some of them are going to be stable in the fridge, some of them are stable in the freezer, but most of them are actually good for 9 months, so an entire school year, if stored as indicated in the kit literature. So follow your protocol, store them as indicated. And the biggest thing is, if you have any questions, just call us or email us. Again, we have a very responsive team, and one of our technical support scientists will get back. We'll be happy to help you out. All right, so next slide. So splitting up ELISA kits. So this is kind of along the same lines as the restriction digest kits, in that there are reagents that need to be prepared once. But again, you might have that Monday, Tuesday versus Thursday, Friday kind of pod schedule that a lot of schools are moving to right now. And, how do you prepare the reagents if you have students doing experiments at, days and days and days apart? And so I'm going to talk a little bit about the steps that you can do. Most of it is going to be exactly the same as in your protocol. But I will say that a lot of the ELISA do have temperature and time sensitive reagents included. And this is because they are real ELISAs. They are authentic ELISAs. And there are antibodies and antigens involved that will degrade if not handled properly. And so, while we do want you to prepare everything as close to the experiments as possible, we know that might not be realistic this year. And so we've actually gone and done some testing to make sure that this works properly in your classroom when you need to split it up into these A/B week schedules. And so we've always tried to be as flexible as possible with preparation for our experiments. Most, if not all of our experiments, again, do come with detailed instructor's guides that can tell you how long your prepared reagents will last. So again, here's the ELISA, and you can see this is a screenshot of the page from the instructor's guide manual, the instructor's guide. And it's going to tell you it's going to identify the component, how to prepare it, and when to do it before the experiment. So our green ones are the ones that can be prepared pretty much at any time. So for the ELISA, this will be our wash, one example is the wash buffer, the dilution buffer. So these you can really prepare anytime before the experiment, and they are fine. They will last, you will store them as noted in the protocol. So here it says stored in the refrigerator. And you'll store them there until the time of the experiment, and you're not going to have any problems. Now, our yellow reagents are the ones that are sort of time sensitive. So we really, for best results, you really should prepare them within a week of doing the experiment. So one, like the way antigen, so that's the antigen used, that the antibodies are going to detect in our ELISA. So those, you're going to want to prepare them within that 1 week time frame. And especially if you have a lab section on a Monday and a lab section on a Thursday, and they're going to be using the same reagents, I'd probably prepare them on Monday, just to make sure that you're within that optimal window of preparation for your reagents. I definitely wouldn't make them any further than a week out from the first time you're going to use them. For best results, again, you want to stay within that time frame. Now, there are some reagents that do need to be prepared closer to the time that they're used. And for the ELISA, one reagent is, and you can see it labeled in red here, it is that secondary antibody. And this is a sensitive one. It is a sensitive reagent. We are aware of that. And what we did was, when we realized how people were going to have to be flexible for the school year, we went and did some studies in our lab to figure out how long we could stretch that time to kind of work with your schedules. Because we did have a lot of people who were talking about that A-B schedule. So again, people trying to offer in the same lab. They're trying to offer it on different days in the same week, where they have students on a Monday and a Tuesday. Wednesday is the school cleaning day, and then there's students on the Thursday and the Friday. And so, we want to make sure the experiments work for all of your students that would be done that week. So we tested both the secondary and the ABTS, so the enzyme substrate that's going to turn color in the ELISAs. And we tested them for a week, storing them in the refrigerator. And what we found is that, the best results are within that 24-hour window. You get great, beautiful results, but you can extend it up to 5 days after preparation and still get great results. So again, this is a reagent you would want to prepare the day of the first lab section that you're doing it. You're going to want to aliquot it between the groups into the volumes that they would need, and then store the second set of aliquots in the refrigerator until they're needed again. Yes. So if you'll have students on Monday, Thursday, and Tuesday, Friday, I would probably plan on trying to run the experiment on the Monday, Tuesday, just so that they're within that 48-hour window, and that'll work perfectly. Just as long as you prepare the reagents and you're within that 5-day period, Guadalupe, they should be perfect. Again, you're going to want to store them as indicated within the protocol, and it should be fine. So, the ELISA is a tricky kit to split up, again, because some of the reagents are a little more sensitive. We also do get questions about our electrophoresis kits. Let me move my head over a little just so that you can see the writing in that screen. Okay, that should be better. So splitting up electrophoresis kits. Let me center my head a little better. Oh, that's not going to work. It's okay. These are the technical challenges of being live and streaming. So electrophoresis kits, again, this is, we have a lot of guidelines in our kit literature for the best ways to split these kits to be used in multiple sections. And luckily, like, electrophoresis is really easy to split. Even if you had sections a week apart, it would not be a problem. So what you're probably going to want to do is a bulk prep. So you're going to prepare all of your buffer, do all of the dilution, and you're going to want to pour all of your gels at the same time. And so within the literature, in the instructor's guide, there is a bulk prep page, and that'll tell you how much agarose, how much electrophoresis buffer to make. You're going to want to make and pour all of your gels at the same time. You can, once they're solidified fully, you're going to slide them gently off of the gel trays, and you can put them in a Tupperware or a plastic bag under buffer, and they're going to be good for a while in the refrigerator. I've kept gels in the refrigerator probably longer than I should have, with great results. And you can tell that you've kept them too long when you start to see little things growing in there. Granted, the buffer is salt water. It's not exactly the most conducive, but bacteria, microbes are, they are adaptable, and they will live wherever they can find a nutrient source. I would say probably make the gels. You're going to want to use them within a week or two, especially if you are using CyberSafe in your gel. So CyberSafe is a fluorescent DNA stain, and that stain, you put it into the gel before you pour it. So you melt your agarose, you cool it to 60 degrees C, and then you put in the CyberSafe. The only caveat I would say with the CyberSafe is you are going to want to add a little bit to the buffer that you are storing the gels in, because over time the CyberSafe will diffuse out of the gel, and if you have some in the buffer, you're kind of meeting an equilibrium, and your gels will keep the CyberSafe in the gel. So next, you've diluted the buffer, you've poured the gels. That's really the hardest part of your prep, because all of our gel DNA and dye ready to load electrophoresis kits, those are going to come with our quick strips. And so the quick strips are great. The aliquoting is already done. If you have 5 sections on a Monday, 5 sections on a Tuesday, you just split out and divide up the quick strips as necessary. You're not going to have to worry about anything there. Same with if you have a Monday, if you're running the lab on a Monday and a Thursday, you're not going to have a problem with aliquoting and storing the reagents. Just store them as indicated in the kit literature. So there's no extra prep for that step. The one thing I will say is that the results are really easy to analyze too. Dye gels do need to be visualized immediately after electrophoresis. Those gels cannot be stored in the refrigerator because the dye will diffuse, and within a day you'll basically have no results on the gel. But if your students don't have time to analyze it in class, everyone's likely got one of these around, a cell phone. So you can just take a cell phone picture or use another camera, take that picture for your students to do the analysis of their results. Now with the DNA gels, you can actually store those gels for a week or longer. I mean, I would say stay within a week, but you could go longer if you needed to, if you store the gels properly after electrophoresis. So basically what you are going to do is following the electrophoresis and the gel staining, you're going to place each gel in a plastic Ziploc bag. And you're going to add a ml or two of electrophoresis buffer and put it in the refrigerator. So this will basically keep your gel hydrated, so you're not going to have any dehydration. Your gels aren't going to shrink up. I don't know if you've ever left a gel on the bench for too long, but the water diffuses out and you're just left with like a thin agarose film over time, or they get like little and wrinkly. So you'll put it in a plastic bag, put a little bit of electrophoresis buffer in the bag, zip it up and put it in your fridge, and those gels can be visualized for over a week. Again, I like to say keep it within a week for best results, but we've definitely done it for I've definitely personally done it longer and still gotten great results. And there is a blog post where we go in depth in about how to store your gels after running them. And so if you fill out the link that's in our chat window, we'll send you the slides from this presentation and you'll be able to click on that link to go right to the blog post. So transformation, go to the next slide. Transformation is another experiment that a lot of our teachers are trying to do this year, and we're not sure how it's going to go because, again, classes are split up. But again, this is an experiment that is not difficult to split up. The vast majority of the prep can be done well in advance of the lab. Your plates can be poured and stored in the refrigerator for weeks. And in fact, sometimes I find older plates to be better for transformation than newer ones because that moisture that accumulates on the surface of the plate and on the lid has time to, evaporate away. And so with the gels being a little drier, your colonies are sometimes a little better. They are not as smeary and you don't get that moisture on the plate. But you don't want to go too long because the antibiotic will break down over time. So you can probably pour those plates up to a week or so before you actually perform the experiment. The DNA, the calcium chloride, the recovery broth, all of those can be stored in the refrigerator, aliquoted previously and stored in the refrigerator. I just want to emphasize, though, that the recovery broth should also be aliquoted. I know a lot of teachers do like a transformation station where the water bath is next to the recovery broth, next to the ice bucket. So if you're transforming, you just kind of go to one location within the lab and do the 3 steps. But the problem is the recovery broth does not have antibiotic in it. And if you're opening it up and allowing students to go in and out of it over multiple class periods, over multiple days, you're increasing the risk for contamination. And now that should be taken care of when you have the antibiotic on the plates. But if your recovery broth is growing stuff, you're not going to want to put this, bacterial soup into your freshly transformed samples because you're not going to get the best results. So if all the sections are doing it on the same day, it's not a big deal. But if you're doing it over multiple days, over a week, you're going to want to make sure to have separate pools of that recovery broth. Now, the key step, and the one step you have to be really careful with the transformation protocol, it's going to be your source plates. And so we have found that for best results with transformation, you really want to streak those source plates 16 to 20 hours before you're using them or so. So basically the day before your experiment. And this is, we found, is critical for success. But again, we've made that easy with our reagents. So with each kit, you are getting more than 5 Bacto beads, and you're getting 5 source plates. And so what you will do is, if you have classes if you're running the lab on Monday and Thursday, let's say, you will have to streak out some of the plates on Sunday, at home or, in your lab going for an hour, streak out those plates. And then your plate will be ready for the next day, next day's transformation. And then if you're doing the lab again on Thursday, on Wednesday, you would streak out the plate and incubate it beforehand. Now, if you let those plates go too long, you just don't get good results because those bacteria start to get starved. They build up their cell walls. It's just a lot more difficult to do the transformation. But again, because you have separate plates, we send the bacteria in our Bacto bead format. We just make it really easy for you. And so you'll just streak out those plates on separate days. After the transformed bacteria have been incubated overnight in 37-degree incubators, the plates can be stored in the refrigerator until the students get back to them. So you do the experiment on Monday, the students incubate overnight, they pull out their plates on Tuesday, they can look at the results. But if you're doing something like, if you have a student on a Monday and a Thursday, what you would do in your lab is you do the transformation on Monday, you would take out their plates on Tuesday after they've grown, and then you would wrap them up in plastic wrap and put them in the refrigerator, and they will be good until your students come back on Thursday. And those plates will probably be good for at least a week before you start to worry about getting too many satellite colonies and getting other stuff growing on them. It will happen over time, but you've got at least a week before your plates start getting too funky. Okay, so I've got a little more experiment stuff coming up later, but I did get a lot of questions about actually setting up the live stream. And so, this is actually something that I learned a lot about over the past couple of months. When we started this, I didn't know how long it was going to last for. I tried to do everything as quickly as possible. And so for me, getting the webcam was using this kind of gooseneck cell phone holder that I found from Amazon. On Amazon, I use a cell phone, and I use some software on my computer to be able to set up these live streams. And so if you're interested in learning more about how I set up the live stream, let me know in the chat or on the form, the Edvotek sign up form, and I could either do a blog post or another live stream about live streaming. But it did take me a little while to find the right software and the free options, because I was trying to do this as quickly and as inexpensively as possible, because I wanted to be able to also help teachers be able to implement the same stuff that I'm doing. And so, it's a little bit nerve-wracking to start live streaming, and a lot of times you feel like you're talking to yourself. I'm glad you're chatting. There's some chat in the chat box because I know that there are people that are listening to me. But I want to be able to help you implement this for the fall if you need to. So I've done a lot of different experiments to date. What you see in this picture is an electrophoresis setup, which is one that people have asked me about. And so it's a really fun and easy experiment to perform for your students. And so in this, so one thing you can do is you can let your students be part of the experiment. If you're doing Zoom or using another video conferencing software where your students can talk to you more easily, or you can set up polls within some of the different platforms, you can actually let your students be part of the experiment. So set up the polls ahead of time. Do I load the sample or not? Do I digest it? What temperature do I incubate it at? Have your students read the protocol, think about it, and guide you. And you can kind of have your students vote, and whatever the highest one is, the highest option is, you can do that step. And it's fun because the students are going to guide you. And if they make mistakes, well, mistakes are part of science. It's part of the scientific process, and it's going to give your students an opportunity to talk about why one thing was wrong, why one thing was right, talk about failure in experiments, really evaluate what was done, and to write about it in their reports. And so I always like to say, failure is part of science. Experiments don't work 100% of the time, and it's important for your students to know that. So in this example here that you see in the picture down there, that was a dye experiment, a dye electrophoresis experiment. And it's actually really fun because you can see those dye bands migrating away from one another in real time. So you can see those separating in real time. I did experiment 101 in my first live stream, which seems like a million years ago. But that one is a great experiment to do in a live stream because the dyes actually migrate both to the positive and the negative electrode. So you have dyes going in both directions. So we did get a question in our live chat. We did have someone ask if we do a specific isolation. So no, we do not have that specific isolation available. So I'm not sure what species that is offhand without doing a little bit of Google searching. Can you tell me a little bit more about what the isolation is that you're trying to do? Now remember, a lot of our experiments are for educational purposes. And so, we adapt them for the education classroom. Okay, so my secret in the back, my secret helpers in the back did a quick Google search for me and mentioned that this species is a species of cyanobacteria. We don't have any experiments that specifically isolate cyanobacteria. I don't know personally what kind of bacterial growth medium that they need to be grown on. I could imagine that if you wanted to do a DNA isolation, you could potentially use our DNA extraction kits. But I think that for something like that, I would reach out to us at info@edvotek.com, and we can basically help you figure out if there is a way we can work with you. And I did get another question just from Rachel. So yes, so if you order your kits today, we will send them with a perishable coupon. And definitely go back in the chat. And if you go back in the chat, there is a form that you can fill out. And we'll send you the slides and all the information and the link to the live stream. But yes, so if you order your kits today, you're not going to get perishables. You will get a perishable coupon, and perishable coupons do not go bad. They do not expire. You can use them anytime this school year or school years to come. So, and the only thing I mentioned is if you're not doing it this year, if you do get to it next year, just give us a call before you order, like when you're ordering the perishables, and talk to a tech support scientist just to make sure there weren't any changes in protocol between the kit you have the box for and the reagents that we have at Edvotek. So every so often we tweak the experiments to make them better, and we just want to make sure that everything is compatible. Okay, so setting up your live stream. So DNA, getting back to DNA electrophoresis. So we did talk about, running dye experiments. Again, DNA experiments will need a second step after you run them. So dye experiments, you can just watch them separate in real time. With DNA electrophoresis, there are two kind of ways you can go. There are two stains that you can use. One is a visible DNA stain, and one is a fluorescent DNA stain, and both have pros and cons. So with the visible DNA stains, you don't need to use any additional equipment to stain them. You'll basically be using, you'll use a stain that looks at the DNA and it stains the DNA dark blue on a light blue background. And you'll be able to visualize that without the need for another system. So it's nice if you have a white light system at home. If you don't, it's no problem. You can still see them if you put them on a white piece of paper. The problem with that is that the staining takes a longer time. So from adding the stain, destaining, it can take up to 30 minutes. And that, if you have some teaching to do in that 30 minutes, that's great. But if you don't, there are two ways that you can handle this. One, you can send your students the results the next day or the next live stream that you have together. You can show them the results of the gel. again, I told you how you could store those gels for days. The same way you would do it in the lab is the same way you would do it at home. You would run the gel, store it in the fridge until you're ready to show it to your students. The other option is the Betty Crocker approach. So you run through the experiment together and then you bring out the final product to show them the results. Either of those are great. I did the Betty Crocker approach for our DNA fingerprinting workshop, because I wanted to have results to show you at that point. With the CyberSafe, the staining is fast. You add the DNA stain to the gel, so the DNA is stained while the gel is running, but you do need to have a UV or blue light box to visualize the DNA at home. So you do have to have an extra piece of equipment if you're using our M12 system. But here's a fun fact that I just learned about our True Blue. So if you are doing experiments at home and you're doing the DNA electrophoresis and then you're also doing transformation at home, which is an experiment that I'm hoping to cover in an upcoming live stream. So when I learn tips and tricks for doing that at home, I will share them with you in my live stream. But if you are doing them at home, you can actually use the True Blue to excite GFP in those transformed cells. So GFP and True Blue both excite and emit at similar wavelengths. And so, we can use the same piece of equipment for both those experiments. And so if you attempt a transformation at home, you only need one piece of equipment. Now, we did a question in the chat box. Are we working on vaccine development for COVID? No. So Edvotek is an educational biotechnology company, and we are developing experiments to help instructors be able to teach about COVID and about vaccine development and about biotechnology in the age of a pandemic. But we are not developing any pharmaceutical products ourselves. But as a concerned citizen, I am certainly keeping my eyes on vaccine development because, I will be signing up for day one to, make sure to get me and my loved ones, protected from this virus. All right. So next slide. Again, I was talking a little bit about the electrophoresis setups. Now, we're talking about this for live streaming, but one consideration is also what if your students are learning, distance learning, remote learning, you might actually set up a loaner lab program so that your students can run some of these experiments at home. And so we have two fantastic electrophoresis systems that would work really well for both live streaming and for the home scientific demonstration experimentation. I've been using the M12 and the DuoSource for my live streams. That's the electrophoresis chamber and the accessories and the power supply. And so if you want to see how that looks in a live stream, you can go to one of my previous live streams. This is our tried and true classroom electrophoresis experiment. It will work the same way in your home that it does in your classroom. Excuse me. And again, this system is going to work great for dye and DNA gels. But if you were sending it home for DNA gels, you might need an extra piece of equipment. You'd have to send that True Blue home too. And so we also have an option, which is the Edvotek Edge. And so this unit is fantastic because it combines the power supply, the electrophoresis chamber, and the visualization system all into one awesome looking unit, I think. It's small, it's compact, it would be easy for students to take home. I'm planning to feature this system in an upcoming live stream so you can see how it works and how it performs. And it would be a great option for demos or loaner labs. So again, if your students aren't available to come to class, you could possibly send the equipment home with them and watch the video on how to use it. You can even coach them through it, and then they can try it on their own. And so if you want more information on how to implement this kind of loaner lab program, please email us at curriculum@edvotek.com, and one of our specialists will work through the setup with you. So, okay, so I do have a question. I'm with Project Lead the Way, and I use a lot of your kits. I always have a problem with the PTC lab and getting good results. And you do follow the directions exactly as written, and you're getting problems with distinct bands. So, there are a couple places where we see, where we can see better performance with this kit. One place I can think of in particular is the DNA extraction. We do find that what you're using to do the cheek cell wash is critical in ensuring experimental success with the experiment. It could depend on how you're running and staining the gels, what electrophoresis system you're using, because, Edvotek is a fantastic, our electrophoresis offerings, I will say, are research grade. We use them for all the development in our lab, research and development in our lab. And, as a molecular biologist myself, I have used a ton of different electrophoresis systems. And I find that ours perform with the best of the research grade systems. Some of the other smaller education-based systems don't give you as great results, especially with those small bands. So one thing I would ask is what electrophoresis system you are using. Are you using our electrophoresis system? If so, that's a place for us to follow up. And you're going to want to make sure that you're using the right kind of gel. With our kid, I need to go back. Oops, sorry. I was clicking around because I have, I have my colleagues, who are helping me read the questions at the same time that everything is going on. Where did my live stream go? Oh, there it is. Sorry, it's in a different window. Another thing is to make sure that you're using the 2% TBE gel, because that is a gel that is optimized for those small gel fragments, and will help you get that good resolution between those bands. And so one thing I would say is I want you to email me. Oh, so you're using our electrophoresis system? Okay, great. Are you using the 2% TBE gels? If you are, I would encourage you to reach out to us, for more guidance. We want you to try and set up and run the PCR in the same lab period. If you kind of incubate the bead with the primers and the DNA sample, you will get some degradation over time. So you do want your students to do the cheek cell prep. That is a place where I believe you can still freeze the samples right after the cheek cell prep. You would have to freeze them right away if you can't set up the PCR in that period. But then once you set up the PCR reaction with the primers, the template DNA, and the beads, I would get that in the thermocycler right away and run it as soon as possible, because that is a very crude DNA prep. So, there are going to be, enzymes around that can degrade the DNA that will affect the tack. And you want that to get in the thermocycler as soon as possible to get the best DNA amplification. And then the restriction digest, there are also places for optimization there as well. If none of these have kind of met your concerns, if you're following those, I want you to email us at info@edvotek.com. And specifically ask for me in that email, and I will work with you to go through the protocol and figure out where we can make sure to have your best success. So I hope that helped. So points to consider with live streaming. Don't require your student. I've been reading a lot about live streaming lately, and I'm doing it myself and getting questions. And so here are a few tips that I have found helpful. Don't require your students to turn the cameras on. Students might not have the best internet at home, and so that two-way video can really affect the performance of their computer and of the live stream. And you also don't know where they're participating from, and you don't want to create any feelings of resentment between students. So some students may need to go to a public library or another shared space to get internet access, and other students might be dialing in from their fancy computers at a different, just be in a different location, a different socioeconomic class, and we don't want to create resentments. We don't want to have siblings on camera, if you're sharing a room, and so we want everyone to be comfortable in that learning space. If a student asks a question in the chat, be sure to read the question out loud before answering. So the students, for me, I know, I'm looking at my computer screen. I'm trying to maintain eye contact with the camera. I have notes in front of me to make sure I stay on track. I'm not always getting to the chat window, and your students are going to be distracted the same way. So be sure to read the question out loud before answering. This is just a good way to make sure that everybody's on the same page with what you're talking about. And this is a good tip for big lecture classes too. Someone in the back might not hear the question. There will be a lag time in responses. And so you want to find creative ways to fill the pauses. And so I found a Twitter thread that I found really useful, and I loved this tip. And the link to the thread is in the bottom of this slide. But they wanted you to find creative ways to fill the pauses. And so they said that the Twitter, the tweeter said that they were at a workshop online where music was played for longer pauses, and that was really helpful. It indicated that there was a mini work period to address the task or question asked, but they would only recommend this for breaks that are longer than 2 minutes. So if you have your students working on something, put on a little music, or come up with a little activity in that waiting space. And then make sure to record the sessions for all students to watch later. As I find myself, sometimes people need to leave, things come up, they can't make it, or I have teachers who have wanted to participate, but their internet went down right before the live stream happened. And we record everything. You're going to record the sessions for students to watch later, and put them online or put them in your learning management system. There are bound to be technical problems at some point that keep students from logging on, but your students shouldn't be penalized for the technology problems. Okay, a couple more teaching strategies. Again, some of your students you will have never met in person, so film a short introductory video to introduce yourself to students. This can be posted to your learning management system or a classroom chat board. And that's going to let students see you and get to know you a little bit before starting class, because you're not going to have your normal, especially if you're teaching remotely, you're not going to have that normal, getting to know you period where, you're feeling each other out. And so this kind of will give your students a little bit of comfort with you before coming to class. Test your content on multiple devices. So because I'm streaming to YouTube, I know that YouTube is mobile responsive, but depending on how you're doing it, you might have students who have fancy computers, and you might have students whose only web access is on their cell phones. And so you want to make sure that your content works for all devices and even old devices. You can couple pre-recorded videos or readings with critical thinking questions that can be discussed on a discussion board like Slack. So you can identify videos and resources that can help you teach. Edvotek has made a ton of them recently with video tutorials that are on our YouTube page and our Edvotek at Home lessons and other free resources that we are providing for our teachers to be able to complement the hands-on experimentation and the live streaming experimentation that's going on. And so while you may decide to record some of your own lectures, you really don't need to reinvent the wheel. We have content, but there's also a lot of great content out there. Through the Khan Academy is one I like, the Amoeba Sisters. There's a lot of really great information and scientists who are streaming about their work. You do want to watch it first to make sure it's real science and not fake news. But be easy on yourself. Create some of the content, but there's also a lot of high quality content out there for you to use. And then you're going to want to create a discussion board where students can support and help one another. And so this is a place where you might not want to participate to allow peer-to-peer interactions to form, but you will want to monitor that space for appropriate peer-to-peer relationships and make sure there's no inappropriate actions going on. So this is actually getting back a little bit to what you were talking about, Thomas, I need to, sorry, spam phone call. Whoops, I forgot to silence my phone first. I'm a bad student in my own class. Okay, there is a follow-up question about ordering through PLTW. How can you communicate which kits come with perishables and which come with the coupon? So this is a question that I'm going to wait for I have a customer service rep who is on the live stream with us. And she'll be able to answer that question a little bit better than I can, because I'm not as one of the technical scientists. This is not something that I know. But what our tech service team is recommending to do, if you order through PLTW, to communicate which kits come with perishables and which come with the coupon, email us at info@edvotek.com and we will be able to help you out. That will be the best route to get that specific answer for the kits that you're curious about. So one PLTW experiment, and very common experiment in classrooms across the country, is our 345, the PTC tasting experiment, where students will sample their cheek cell DNA, and they will sample their cheek cell DNA, extract it, amplify it using PCR, and evaluate their results. And so in the time of COVID, you could imagine that you don't really want students. I don't know what the safety protocols are going to be in place in your lab, but I'm going to assume that all your students are wearing masks, and we don't want them spitting and creating aerosols in your classroom, washing that saline around. It's just a really, even in areas where infection rates are low, it's just a really, it is a suboptimal situation for doing this experiment, because we don't want people putting stuff into their mouth that could be potentially infected. We don't want people expelling out that saliva that could potentially have virus particles. And so we've actually gone back to the lab and done some research where you can actually extract DNA from the sheath cells on the human hair. And so again, it's a replacement for that cheek cell protocol. I'm going to say the cheek cell protocol is still the best way to do this DNA extraction. And if we weren't in the time of COVID, I would be saying 100% do the cheek cell extraction, especially using saline for that mouthwash. Our experiments don't work with Gatorade. You just don't get results. But this is the best way to do it right now that is not going to require fluid transfer. And so your students are going to remove hair. They can either do I find eyebrows work well. You can also do the hair on your head. You're going to pull out that hair. And you're going to follow a new protocol that we've developed, which is available on our website. If you, again, fill out that form, the link is in the chat window. We will send you the slides, and in the slides, you'll be able to click on and go to the protocol. But basically, you'll be isolating the hair from those sheath cells, the DNA from those sheath cells. And now when you pull out the hair, the most important thing to do is to make sure that you can see those sheath cells on the hair. Because remember, hair itself is just keratin. Keratin has no DNA. You need to make sure to get those cells that are building the hair in order to extract the DNA. And so we've tested this protocol and had great results with all of our human PCR kits, including the PTC tasting kit. All of the reagents for DNA isolation are included in the kit. And so actually we have the link to the hair cell DNA extraction protocol in the chat window now. So if you want to take a look at it, you don't want to wait to get the slides, you can click on that link right now to download that protocol. All the reagents are included in the kit. And then for more information about how we did it and the work we did to create this protocol, you can check on our blog post at blog.edvotek.com. So we have created a series of free online resources to help you teach every topic. We have a series of Edvotek at Home experiments, and these are like paper-based virtual experiments where your students read through the background literature, they read through the protocol and answer questions about what's going on in the experiment at different points in the protocol. They evaluate the results, and we have a series of study questions and a PowerPoint presentation that your students can go through, that you can use in your own teaching. This is also a great way if you actually have your students coming in a hybrid schedule, this is a great way to do the pre-lab prep. So if you're running an electrophoresis experiment, you can have them do the electrophoresis Edvotek at home experiment to kind of get oriented to what they'll be doing in the lab and to really think about it critically. And then when they come into the classroom, the preparation work is done. You can spend that valuable in-class time actually doing the hands-on work. We have a lot of video tutorials on our YouTube page. You're on our YouTube page now. You can take a look at some of them. But they will go through some of our most popular biotechnology techniques. And then we also do have printable activity sheets that you can have your students complete, including coloring pages and word puzzles. Some of these are fun little activities for your students to do, in some downtime. We just wanted to have resources for teachers at every level to be able to teach, and especially virtually, have resources that you don't have to spend a lot of time making yourself. If you are doing distance learning and you want to have hands-on experiments, we do offer an option, and that's our Edvotek MyLab custom kits, which are real hands-on science that your students can do at home. We have blood typing kits, we have DNA extraction kits, we even have we're working on some simulations for some other experiments as well, especially, electrophoresis. We're working on a simulation and hopefully real experiments, but a simulation that can be done at home with your students. And so all of these kits have enough to repeat the experiment in case your students, don't get the best results the first time. We can send all the kits to one address. So if your students are coming to school, your parents are coming to school to pick up kits, we can send all of the kits to one address, or we can send them directly to your students. So if you are contact free and you want your students to do 3 labs, we can box them up and send them to your students. And we have a wide variety of biotechnology experiments, including DNA isolation, forensic blood typing. We actually have a COVID antibody testing simulation, which is very popular right now, and it's an amazing experiment for your students to do at home. And we do have a chromatography experiment, and more. So I would definitely go on our website, take a look. If you have any questions, you can email us at info@edvotek.com, and we'll answer all your questions as soon as possible. So that's what I have prepared for today. If there are any other questions, please put them in the chat window now. I'm going to kind of wrap up a little bit about Edvotek, but I can answer any questions that you have. And so to request this presentation and to get your professional development certificate, again, please be sure to follow that link that we put earlier in the chat. If we could get that link put back in the chat, the form request, the slide request / professional development certificate form, let's get that back in the chat. If there are any additional questions or concerns that you have, you can put them in that form too. I'm also looking at changing the time of our live stream. So with teachers going back to school, 1 o'clock Eastern time doesn't work for anybody anymore. So we might start moving them to the evenings. So if you let me know what time would work for you and the time zone that you're in, we can kind of shift the time of our live streams. Again, if you have any questions, we pride ourselves on creating a quick and hassle-free way for you to contact us and to get answers to your questions. Phone us at 1-800-EDVOTECH. That's between 9 and 5 Eastern time. Our email is always open, info@edvotek.com. If you have any questions, send them to us and we will get back to you as quickly as possible. We have our YouTube channel where we have all these a wide library of videos to help you with your teaching. And then we are also active on social media through Facebook, Twitter, and Instagram. And that's also a great way to get in touch with us. Or what I'd love to see are your results. So if you share your results with us, make sure to tag us in one of these social media channels. And we do send out thank yous, special thank yous to our teachers who give us results. who share their results with us. Because we love your questions, but we love to see your good news too. It's 2:00 now. If there are not any other questions, I just want to say thank you so much for joining me. I hope I helped ease your transition into teaching for this crazy school year a little bit. Again, if there's any way that we at Edvotek can help you, don't hesitate to reach out to us. We want your experience to be as good as possible. Oh, we see someone after 6:30 my time. Okay, so your classes finish at 4:15. Great. Thank you so much for sharing that with me. We want to make sure to have a great time for you to be able to participate. So thank you everyone for joining us. Again, we'll see you back in a live stream in a couple of weeks. Have a great day and stay safe. End stream.